Hello, and thank you for joining us today for Singularity University's Which Way Next. I'm Jonathan Knowles, faculty chair of the design track here at Singularity University and senior strategic advisor to the CEO and CTO at Autodesk. We're here today with Dr. Louise Leakey, famed paleoanthropologist. Louise was brought up in Kenya. She's a fourth-generation Kenyan. She has been continuing the Leakey Legacy in search of our origins through her research in the Turkana Basin of northern Kenya. She's the daughter of renowned paleoanthropologists Meave and Richard Leakey, and the granddaughter of Louis and Mary Leakey. She's also a National Geographic Explorer in Residence. For 35 years, the work in Turkana Basin has made it one of the most comprehensive efforts in the field organized to explore human origins and evolution. Now, in addition to her work in Turkana Basin, Dr. Leakey works closely with local communities in Kenya to augment funding for education and healthcare. Dr. Leakey lives in Kenya with her husband Emmanuel and their two young daughters. She's an avid photographer, a conservationist, a pilot, alumni of the Young Global Leaders, and she sits on the advisory board of Sea Shepherd International. Among her other pursuits, she manages the Leakey family vineyard on the edge of the Great Rift Valley, where they produce one of East Africa's finest Pinot Noirs. Louise has recently been involved in an initiative with Autodesk to bring the fossil collections housed in the National Museums of Kenya and Lake Turkana online to make them more accessible to the public and teachers worldwide. Dr. Leakey, it's great to have you here today.
Thank you very much. Great pleasure to be here today.
I should say, Jambo Sano, habari yako. And how would you reply to that?
Niko salama mzuri sana.
Wonderful. Yeah. I love Swahili. I found it a very easy language to learn.
Oh, good.
Actually, did you? Well, you grew up
We
learning
grew up
it, didn't
speaking
you?
Swahili, so it's a sort of second language,
It's
second
wonderful.
nature.
I still I lived in Kenya many years ago, and I have a passion for the Kenyan people that survives to this day. So you have certainly had an upbringing different from most. Tell us a little bit about growing up in Kenya with your renowned family.
I guess one didn't really think of it as any different because we were out with them during the holidays when they were up at Lake Turkana looking for fossils. We grew up in a very basic rustic hut on the lake shore in those summer holidays where they would be out for long hours during the day and we would be left with a nanny and we would walk down to the beach and find crocodile teeth and crocodile eggs and things like that. So a lot of nature was surrounding us all the time. We'd have lions killing things on the beach in the evenings, and that really became a very passionate place for me to be a part of. So that was Lake Turkana in the old days. Things have changed somewhat today. But I had a formal education in Nairobi. I went to a convent, in fact, for my primary education, and then went on to a boarding school in the Del Monte pineapple plantations, where I studied the British curricula, and then left to go overseas to do my university education, and have returned back to Kenya to be part of, the discoveries going forward, and picked up this profession as my work.
So it was your grandparents who really put Africa on the map, who found the evidence in Olduvai Gorge that Africa really was the place that we all came from. Tell us a little bit about the Leakey family and what really is the Leakey Legacy.
So my great-grandparents actually went out to East Africa as missionaries, the turn of the last century, and they established themselves on the Kikuyu Highlands, where my grandfather, Louis, was born in a little mud hut, and he grew up as a child amongst the Kikuyu people speaking the local language, and really felt very passionate about Africa, and was very sure and certain that he would find evidence of human origins and stone tools, which he became passionate about because as a child, as a teenager, he was given a book on the late Stone Age. So he was looking for chert artifacts, essentially, and found lots of obsidian flakes, and that really cemented his belief in and his determination to find artifacts in East Africa, which he did. He found many of them. So he really set the Leakey Legacy on its path. My father worked for him, as did his brothers, Jonathan and Philip. My father's Richard Leakey, and they spent, as I have done, their holidays accompanying their parents to these remote locations looking for fossils. And my father did the same and became sort of, wanted his own patch, as it were, and led an expedition to the Omo Valley in Ethiopia, where he was lucky enough to fly down into Kenyan territory, the Turkana Basin, which is this long lake in the very north of the country, and found fossil deposits there. And so he had his little patch to work on, left Tanzania, where his parents were working, and set that path in motion. And there's so much work yet to be done in this very large remote region in northern Kenya. And so that's where he and my mother focused their efforts, and where I've continued to work alongside my mother on the fossil remains from this region. So that's the Leakey legacy, as it were, that generations have been doing this work. Each have been doing them in their own special way, and we've really got to take this field forward, and that's the challenge that I'm faced with.
And the origins of the Leakey family really were around helping to make the world a better place. Certainly your great-grandparents, when they went to Kenya, that's what motivated them to do so. That legacy has continued as well with your father and his work with the ivory trade in Kenya, and even your work with education and healthcare. There seems to be something that has been taught to you that it's about this scientific research that you're doing, but it's also about, let's make things better. Let's help the people that are local.
In a way, I think being in East Africa gives you quite a lot of opportunity to make a difference if you've got the exposure and the international outreach that we're so fortunate to have because of the legacy that's been built up. And I think to be able to be there and put back, by nature of exposing the big issues on the ground, be they poaching, be they sort of corruption in government, which my father has been very involved in trying to prevent and actively was head of the civil service for a couple of years under the Moi government, and now building up an institute with international recognition on the ground to enable people to come back to that region and do work and really drive the science forward. I think that really has an important role to play for people worldwide and to open up opportunities and awareness.
And the legacy goes even further with the research into other primate studies, thanks to your grandfather as well.
That's right. So my grandfather, Louis, was instrumental in engaging Diane Fossey, Biruti Goldikas and Jane Goodall. And in fact, my mother, Meave, actually went out to East Africa to work for Louis in running the Primate Research Centre. And so modern primate studies, he believed, were essential in helping us to understand behavioural patterns of our ancestors. And so those studies have actually been long-term as much as the paleoanthropology and the research that's been going on in the Turkana Basin and continued today, whether they're the gorillas or the Jane Goodall Institute, Biruti's efforts in Indonesia as well. So they really set a path in terms of our understanding of the path, and his vision it really continues today.
Well, it's wonderful that you're continuing that legacy on, and that you are looking at exponentially growing technologies and technology in general and how it can help to continue that legacy started so long ago. On that note, tell us a little bit about, what is paleoanthropology and what do you do as a paleoanthropologist?
Well, paleoanthropology is really the study of past fossils of human ancestors. Paleontology that encompasses all the other fossil mammals and plants and other things that coexisted with the human ancestors. Then, of course, you've got archaeology as well, which looks back at the stone technologies and the tools that were being made by these ancestors. So all of these disciplines are very much part and parcel of the study that we're undertaking in that region, and goes alongside with detailed studies of the geology. And you can look back in terms of isotopic studies, which give you some detail in terms of diet, and then you've got climate records that are preserved in the cycles and the sediments. So there's a very elaborate picture that can be drawn from multiple disciplines in this region, and that now, when you bring that all together, gives you a much better understanding of what happened over the past 8 million years. By no means have we got all the answers, and we're looking at little slices in time where the evidence was preserved, but more often than not, things have been eroded away and they're not preserved. So we can only say as much as the evidence that we've found from this region.
Well, tell us a little bit about Turkana Basin.
So the Turkana Basin is essentially a depression. It's the Rift Valley that runs from the Gulf of Aden all the way down through to Malawi is a big fault, a geological feature that you can actually see from outer space. But because it's this depression, rivers flow from the basin margins, the edges, the highlands, and form lakes and slow-moving rivers through time. And these lakes have filled up with sediment, become rivers, and it's very dynamic, constantly changing, and has done since the rift really came into being. And so these rivers carry the sediments that are brought down from the erosion of the highlands, and they are deposited in these lake basins and bury the bones of the animals that lived in that region at that time. And so when you get this rapid deposition covering the bones of animals that lived alongside those waterways or in those lake basins, then you get the opportunity to preserve these fossil remains. And so the Turkana Basin had all the right qualities because it's this depression. You've got these lakes, 7 or 8 of them through the past time, and many of these fossil remains were preserved there because it's again a geological feature, very active, moving, faulting. You've got sediments that are then faulted up and brought back to the surface, and you get erosion through, so you're finding fragments of bone on the surface. And then you've got a great geological sequence in terms of volcanic ash layers being deposited through time, and those ash layers you can actually date accurately and get a chemical signature on their composition, so you know exactly where you are in the time sequence. So you can place the fossils very accurately. So a combination of all of these factors mean that this is an exceptionally good field laboratory for not only preserving the remains, but for finding them and actually using this information to understand our past. So it's a tremendously unique and large area, and there really is nowhere else in the world quite like it. Richard really found an important patch, didn't he? It's enough to keep him busy for several more lifetimes, yeah. But we really now have moved towards engaging many more people so that we can actually accelerate the results that are coming out of this region. What are some of the most significant finds that have been made there in Turkana Basin? There are many really significant finds. If you go back to 1968, 1969, which is when they first started working in there, those fossil fields, and they're probably some 4,000 or 5,000 square miles of fossil-rich deposits, and they were walked by a small team of fossil hunters, literally looking for fragments of bone on the surface as they traversed these badlands. And they were finding exciting and just never seen before remains across this entire region, which were just totally unknown to science. And so you had 1972, this tremendous skull of a early Homo called Homo rudolfensis. Now you had the Nariakotomi boy, which was found in the early 80s, 1983, and it was a skull and lower jaw that was intact, which then when they began to expose more of the hillside, found bits of the ribs and long bones, and you've got this complete skeleton of Homo erectus at 1.6 million years. I think that's probably one of the more impressive and dramatic discoveries. But there are many more, and every single hominid that's been recovered has this amazing story to it and has contributed significantly to our understanding, and quite often throws the whole interpretation on its head, because you've got to accommodate this, or it clarifies some misunderstanding or a question that one couldn't really pinned down. You may have had a hunch about it.
Yeah, I can't think of any other place I've heard of where so much of this seems to come from.
Well, we know pretty much for certain that all human ancestors came out of, or certainly out of Africa. That is
Homo erectus came out of Africa.
There's no doubt about that.
Right?
Homo erectus was the first human ancestor to leave Africa 1.8 million years ago. Whether that evolved in East Africa or further south or to the north, these are still questions that we haven't quite yet resolved, but we certainly have Homo erectus in the Turkana Basin. Whether or not it extends further south is something that's up for debate still. But humans and our ancestors evolved in Africa. When I say humans, I mean Homo sapiens, ourselves as well. And we left Africa as recently as 75,000 years ago to populate and have our diverse natures across the world.
I know it's not your field, but it's got to be very exciting to see what's going on with genetics these days as we apply that study to watching how populations have come out of Africa and spread around the world.
The genetic story is extraordinary. It's exciting. It's unquestionable, and it really is interesting ground, and it's certainly backs up what the fossils have been telling us. Unfortunately, we can't take that back too far. In terms of extracting DNA from fossils is sadly not possible, but you can certainly look back in time considerably far with the genetic story.
I think it's about 10,000 years-ish that we can
yes, and even
get some idea with haplotypes.
That's right, and I'm not sure, I mean, who knows whether some of the fossil material from that time frame they may be able to extract DNA from this, and certainly people working on this now as well.
Waiting to see what the movie version of the Leakey story looks like, the Michael Crichton sort of version of it, like what he did for Jurassic Park, but
right.
Looking at the stuff that you guys are finding. And
one day, we've always said if we were working on dinosaurs, we'd have a lot more support, but we need to somehow popularize the field of human origins again, and I think, as you say, by putting faces to these old fossils and to making them be more accessible to people in terms of where they can print out digital models or rotate these things and play games with them, then I think we're onto something. And I think this is where it's leading in terms of just engaging people and getting them to open up their minds, because there is such a fascinating story to be told, and there's a lot of resistance to engaging in that because of the religious movement, particularly in this part of the world and elsewhere. But I think it's extremely important to give people the opportunity to think and feel and look and think about it.
Well, let's talk more about that in a minute, but before we do, let's talk first a little bit about low-tech versus high-tech paleoanthropology, and compare about how you do what you do today versus the way that your mother and father did their work.
Well, we actually still find the fossils in the same way. That we haven't got around the fact that we actually need to go out there with a team of trained fossil hunters and look for fragments of bone that are on the surface. And you have to walk these areas. We still aren't able to find areas without getting in there on foot.
We're talking very small things here
We're talking about finding a tooth, for instance, that's sort of black
looks like
and
a stone
shiny.
or a stick.
It's a small size of a dime or smaller sometimes, and you need to be able to recognize what species that comes from. Now, I should add that the human ancestral remains, they're very rarely complete, beautiful skulls that you see in the pictures. They're usually made up of hundreds of fragments of bone, and so you need to assemble those. And also, the point to make is that the human ancestral remains, the bones that we find of them, represent about 1% of all the other fossils in that region. So we're collecting more often pigs and antelopes and horses and hippos, and they're very much part of the picture. So we have to go out there and find the things first, and that we still do the same way as it's always been done. Now that could change. That once we have high resolution imagery, we may be able to actually open that up and do things differently. When it comes to recording the fossils, in the past they would build a little cairn of stones, and you would have to be on the ground with the fossil hunters, chasing after them so that you could actually identify and collect what was found the same day that they were finding this. Because if you don't keep up with the fossil hunters, you never find it all, you never collect it all. So it was fairly rushed to actually mark the positions of these fossils. They were using a pin on an aerial photograph, and you had to spend a little bit of time with a magnifying glass on the hilltop trying to actually find the exact point that you were standing on, push a pin through and write a little number on the back with card. Now, today we're still transcribing those pin pricks onto more georeferenced GIS systems so that we can actually put the whole database together and begin to answer certain questions. So GIS is a huge tool that we're now able to use and actually put all the information, geological and positions of where fossils are being found, and look at what different species are associated with different habitats. And so these are things that would never have possibly, would never have been possible in the past. Now we have a GPS, we have a digital camera, and we can send the team out with a digital camera and GPSs, and they can record the positions of everything they find during that day. And we can go back to camp and go through those images and actually decide what fossils need to be collected most urgently. We don't have to collect everything. We can collect those that are in most need of being brought in, and people can get back to the sites and put things back exactly where they were found if necessary. So that, added to that, instead of using carbon paper and little things that blew away in the wind, we can use an iPad and we can enter data directly into databases. It's sped things up in many ways. It's certainly enabled us to collect additional data, and this is all sort of big differences for us.
And you're able to also harness the power of technology to create 3D models and even bring things from the real world into the digital world with these 3D models, and then push them back out to the real world so that more people have access to the things that you're finding.
Absolutely. So because traditionally these fossils have all been stored in the museums, in the collections, they're very hard to access unless you're a scientist. And seeing an image in a textbook about a skull doesn't really do much for too many people. It may get me terribly excited, but it really, there's so much more to these fossils if you can see them in 3 dimensions. And so now with technology such as Autodesk 1.2 3D Catch, you can take pictures and build 3D models very simply with an SLR camera, and that model you can throw up online and present it so that anyone anywhere in the world can actually look at it, explore it, if they've got that internet connection. And you can take it further. Classrooms can then print these models. You've got teaching aids. People can actually make up their own collections. They can think about why a fossil such as this resin printout of a 2.5 million year old skull has this big crest running along the top of its skull, which incidentally was to attach its large muscle that powered this enormous chewing apparatus. It had very big teeth, was probably chewing coarse material. But you wouldn't think about that if you just saw that as a sort of 2-dimensional image in a textbook. But once you got this in, you may wonder, boy, that does look strange and different. So it's really opened up opportunities for people to think about it and get excited about the past again.
I remember certainly my textbooks, and the best I could hope for were usually black and white photos of these from the museum. And honestly, even these days, I think of a 3D model spinning around online is, to some people today, almost the same as the black and white picture was to me. But there is something visceral and real and connected when you can hold this thing that is the exact replication of the real thing that was found. It's amazing, and widely, virtually every school around can have access to this. I mean, 3D printers, at the low end are $800.
That's right. It really does open up all sorts of opportunities for education and for inspiring people, students all over the world. And I think the potential for even creating even more simplistic models where you're using the CNC laser cutters to cut out layers in cardboard, and that people can engage in assembling these models, is another way to make it very accessible. And so much so that with a PDF printout on paper stuck on a throwaway cardboard box, we can get these models into classrooms anywhere in the world, particularly in the developing world where you really don't have access to the more sophisticated 3D printers and CNC cutters. But it's as important that these schools, the little classroom that's built out of mud and wattle, and the students who can actually get a printout and use a cardboard box can actually then do the same as a school who is in a more fortunate area.
It's fantastic. So the next step beyond that, I think, is to ask, how does that broader networked community, and even if they are loosely networked with part-time network connections, how does the crowd, if you will, help with your research? Are we really moving into a world where we're going to see armchair paleoanthropologists?
So I think it's fast approaching the time where we will be able to use imagery to this level where we can actually capture the fossil deposits using particularly, say, a drone, unmanned vehicle, as it were.
And you've been doing some testing with this, I think.
That's right, where you can fly a camera, automate it to fly a certain flight path, and have it take images which you can then throw up to the cloud and have people search those images for little fragments of bone, and could give you a position of where these things are. And that has the potential, I think, of real citizen scientists' participation and contributing to the search and recovery, because then we could send teams into those particular areas to collect some of these fossils. Now, we're not there yet, and the imagery, I think, is improving all the time, but to cover the scale of area that we need to cover, I think we're a little way to go yet, but we certainly can get the imagery now. I've been doing that using a kite, even with a camera on it, to be able to show what it is that we're looking for. At the moment, it's slightly more laborious throwing the kite up and the camera and taking the pictures. We could certainly look at that area and find everything that's to be found, but the concept is there. And I think we're fast moving towards a situation that, yes, it would be possible to engage a wider audience. And it's urgently needed because these areas are becoming increasingly populated with humans, livestock, there's development, there's oil exploration in these areas, and it's very much threatened. And this is humanity's heritage that really is only preserved in this area. And so I think to be able to make sure that we're not going to lose this heritage, you're going to need something like that to make sure that we do actually find and collect the evidence that is certainly lying out there, and that our team of 10 or so fossil hunters, with their human nature of being distracted and not seeing things, we miss things, and we will then be able to do a better job of finding them.
So you mentioned human heritage. Now, of course, we're just one of many species on the planet, and in that context, what are some of the lessons that we can learn as we study our past? Why is it so important for us as we move forward as a species to do what you're doing, to study human past?
I think one of the most important things that we lose sight of, and what the past can tell us, is that our history really only goes back 8 million years. That's the last common ancestor with the great apes. We don't know the evolutionary past of the great apes today. It's very, very unusual to find those fossils. And so to liken ourselves, say, to a chimpanzee today, we may be completely wrong. We don't actually have a very good picture of what that common ancestor might have looked like. The hominid fossil record, the upright walking apes, are what hominids are, that are on our evolutionary line, when we look at the fossils, there are all these dead ends. 2 million years ago, there were at least four different species of human ancestors that lived in the Turkana Basin. We're not looking at things that lived outside of the Turkana Basin at that time. And all of these things at some point became extinct. Now, as little as 50,000 years ago, there were 4 different species of human ancestors on planet Earth. And today, there are only us, only Homo sapiens around. Now, that's something you can only understand by looking at the fossils in the past. And to think that we're here for forever is completely wrong. That is not possible. Everything has a time on planet Earth. Now, how long we are here today really depends on how well we do, and I think particularly now, how well we use technology to enable our ability to use or create food resources, or just to exist on the planet and not to burn out, because our population increase is frightening, it's alarming. And that's, as a species, we're not very good about doing the things that actually are right for our survival as a species. We know what needs to be done, but we aren't doing a very good job of holding it together. And I think that, again, looking at the past really makes you consider that in terms of humans today and how far we've come from the sort of very crude beginnings, stone tool technologies that come in around about 3 million years, to today, and where we are with technology and tool use. It's an incredible story, and most of that really has happened in this last tiny slice in time that is part of our species, and most of which is coming after the Industrial Revolution. And you know, it just blows your mind where we're taking this today, and it is one of the marvels of our species.
Dr. Louise Leakey, thank you so very much for chatting with us today. This has been just fascinating.
Thank you very much, too. It's a great pleasure to be here.